what I do first is I take the problem, I draw a line under it, and I create the problem again. The reason I do this is because it's very important that I have the original problem so that I can always refer back to it. If you start doing all kinds of things immediately, you don't get that opportunity. So this is the original problem. I can always refer back to this, and meanwhile, I could begin solving the problem. Now, understand something about solving most algebraic problems. They could be done a million ways. So this is the way that I like doing the problem. My idea would be to bring all of the x's to the left side of the equation. All right, so I get rid of this. Here I get -10, -3x equals -8. And I get the -3 because I'm adding a -5 and a +2. And I'm keeping the sign of the 5, which is the negative, and I'm subtracting and getting 3. Now I have the variable on the left, and I bring the number to the other side of the equation. That cancels out. I get -3x equals 2. And then I divide by -3. That cancels out, and x is equal to -2/3. Now, -2/3, if you put it into the calculator, will give you the following answer. And it'll keep going for as many places as your particular calculator. That's not a good answer. Or, you could write this 0.6 with a line on the top. You could round it off. This is not the exact answer. This is not the exact answer. This is not the exact answer. This is the exact answer. So when you express an answer in this class, I would appreciate it if, it would be to your benefit if you would do it as a fraction. And the answer here is -2/3. Okay? And I would not check this in the normal way that we check a problem, where you take the answer and you substitute it for x and you see if it works out, because that's going to cause you all kinds of problems. And it's going to be more difficult than we started out. So I would suggest simply looking at what we did and doing it over again. Let's see, we brought over the 2, we got -3, we brought over the 10, we got +2, we divided, and that's it. That's the way I check problems. I hate checking a problem by substituting it back, because who feels, it'll become twice as hard as it was to begin with. Are there any questions?
No.
Did anybody do the problem a slightly different way and has a different way of doing it and wants to, know if they did it correctly? How would you know if you did it correctly using a different method?
Another method is you could make one side equal to 0.
Well, you don't really want to do that. You don't really want to bring everything to the left, for example, and make it equal to 0, because students make too many mistakes that way. You're always going to try to balance out the equation by putting the x on one side and the number on the other side. That's what I suggest. Okay? You got the right answer using a different method if you come out with the same answer I got. Then you know that whatever you did was also correct. It's virtually impossible, no pun intended, but it's impossible to do a problem in a crazy way that you know how to do, get the same answer. That's really a very, very hard thing to do. Okay, this is problem number one. These are problems, sometimes I take them from the workbook, sometimes I don't.
Professor,
Yes.
what if you add 5 to both sides and then minus 8 to both sides?
You mean bring the 5 to the other side of the equation? And bring the 8 to this side of the equation? Is that what you're saying? Is that what you're saying? Speak.
No, I'm saying if you add 5 to both sides
Yes.
and then to solve for x, you add 8 to both sides.
Yeah, that's what I just said. Let's take a look. Okay, so the way you did it was to add 5x equals 5x, right?
Mhm.
And you got -10, that dropped out, -8 plus 3x, right? And then you
No.
did this. And then you did this. And then you did this. And you got this. So the question is -2/3 equal x the same as x equals -2/3? What's the answer?
Yes.
Yes.
Of course. As a matter of fact, is it true? Is A equal B the same as B equals A?
Yep.
It is. Can anybody name the property that can be used to solve this? Excuse me. Let me put it another way. Can anybody name the property which makes this true? If A equals B, then B equals A. Does anybody know what that's called?
Is it property of addition?
Marco?
Yes.
No, that's not what it's
Uh,
called. Sorry.
Maybe
Property of
Multiply it
equality.
with
No,
the
no, no,
same
let's-
thing
let's-
with the
let's-
both
let's all
sides.
not call out at the same time, so. Who was speaking? Who was speaking just now? Female voice. I didn't see it.
Okay, what if I mean multiply it with the same
Wait,
number
wait, whoa,
in
whoa,
both
whoa, whoa, whoa.
sides?
You have to answer my question before I answer your question.
Oh,
My
sorry.
question is, what is the property which tells us that if A equals B, then B equals A? What is that called?
Oh, I don't know, sorry.
Can I answer?
Anthony?
Yeah.
All right.
Property of equality.
No.
No?
Symmetric.
So. Say it again.
I said symmetric.
How
Property
did
of
you, where did you learn that?
I'm African. We have
Very
advanced.
good. This is called the symmetric property. Very good. Symmetric property. Excellent. Good work. Very nice. Very nice. Yes, that's called the symmetric property. Very few people know that because very few professors, actually talk about, people talk about the commutative property. What's the commutative property? The commutative property tells us that A plus B is equal to B plus A. You've all heard of the distributive property, right? Distributive property tells us that you know, well, let's use letters. A times B plus C is equal to AB plus AC. This is a very important property that we use all the time. But the symmetric property is a property that I use a lot because when I solve an equation, I like to have the variable on the left and the number on the right. Okay? And when I get this, I usually flip it around to look like this. However, if you did the problem like this and got the right answer, then it's definitely correct. So that was good. Does anybody have a question? Okay. Next problem. I'd like you to try this one. Okay, I'll give you a few minutes to try that to begin. And there I am. I keep the original. I come down here and to solve this problem. All right, now the first thing I'm going to do is bring down the 4, bring down the 7, and do -3 times 2x is -6x, and -3 times +1 is -3, and then -7x. Okay. Now, I see that there's a lot going on over here, so I'd like to combine like terms. The next thing I'm going to do is to combine like terms. So it's your choice, do you feel like combining the +7 and the -3, or the -6 and the -7? I would choose this. -6, -7 is -13x. And then +7, -3 is +4. And I could see immediately where this is going. If you bring over the 4, you're going to wind up with -13x. 0 equals -13x. Now, what I would do at this point, because I don't like the x on the right side, I just don't. I'm going to turn it around and make it look like that because of the symmetric property. I use this all the time. I love that. And now you divide by -13. And x is equal to 0. Any 0 divided by any number is equal to 0.
Professor, I made a mistake, but I still got the same answer.
You made a mistake but got the right answer.
Yes,
I don't like that.
I know, it's weird.
What mistake did you make?
When I distributed, I left it positive instead of negative.
You left,
It was 6, I had 6x plus 3.
and you still got the
Negative.
right answer?
Yeah, because
Wow.
then I combined like terms and I got -13x plus 3. Then I put the 13x to the left side, and then I had 13x plus 4 equals 7 minus 3. And then I got
Well,
13x plus,
but you just said you left this as positive.
yeah, but then when I moved the 13x to the other side, I left the negative there. You see how it says -13x? So I made 2 mistakes, and I guess it canceled out.
Well, that's, I mean, all I could say to you is, when you ever make a mistake, try to make the mistakes in pairs, right?
Yeah, but I'm rewriting it now.
Because when you make the mistake in pairs, one mistake will cancel out the other mistake.
That's pretty
And I would
interesting.
say that you're a very lucky person, and lucky people usually have a lot of trouble with math. People who say, well, I'll get lucky. So I wouldn't recommend that, really, I wouldn't. However,
Okay.
what I would recommend is maybe using, do the check. you're getting an answer which is sort of a strange answer. Students feel a little uneasy whenever they have a problem that comes out to x equals 0. So, write the problem over again. I don't like the check, and I told you that before. I don't like it because, number one, I have to rewrite the problem yet again for the third time. So the more you rewrite it, the more likelihood there will be a mistake. But then you substitute and see what happens here. 4 equals 7 minus 3. This drops out times 1 minus 7x. 4 equals, and let's see, x we should replace with the 0 also, right? So this would become 7 times 0. And this is 0. And you can see that it's going to come out to 4 equals 4. And there's your check. Okay? So that's one thing you could do. It's doable when you get an answer of x equals 0. It's much more difficult up here when we solved the problem and got negative 2/3. That's a much more difficult problem to check. Okay, there it is. Okay, I write it and then I take a look, make sure I have it exactly the way I want it. Again, take time, do that problem. First thing you want to do is find, there are many ways of doing it. Again, and I will always be saying this, is that there are many ways of doing this problem. You could attempt to combine the fractions here, and do the problem that way. Or you could try to get rid of all the denominators. My favorite way of doing this problem is to get rid of all the denominators. But in order to do that, you have to find something called the least common multiple. The least common multiple is the smallest number which all the denominators divide into evenly. And by evenly, into evenly. By evenly, I don't mean that it has to come out to an even number. I mean that it's not going to have a remainder. This is called the LCM. It is very similar in concept to something called the least common denominator, which is, abbreviated LCD. So it's very similar to that. So we want to find a number which 3 goes into, 4 goes into, 6 goes into, and 4 goes into. And, it could be anything. It could be 24, it could be 48, but you're trying to make it small enough so that it doesn't become ridiculously large. And it comes out to be 12. Now, if you don't know how to do that, if you're saying, well, where did he get 12 from? This is where I got the 12 from. I took the 3, the 4, and the 6 and said, does 3 go into 6? Yes. 6 goes into 6, but 4 doesn't go into 6. Therefore, we take the 6 and we double it. And we say, does 3 go into 12? Does 4 go into 12? And does 6 go into 12? The answer is yes. So the least common multiple for this problem will be 12. So that's why I'm multiplying everything by 12. Now, watch this very carefully. 3 into 12 is 4. 4 times 2x is 8x. Now, to check yourself, you could have multiplied 4 times 2x and gotten 8x. excuse me, you could have multiplied 12 times 2x and gotten 24x, and then divided by 3 and gotten 8x. 12 by 3 is 36, divided by 4 is 9. Or you could have gone 4 into 12 is 3, 3 times 3 is 9. 6 into 12 is 2, 2 times 1x is 2x. 4 into 4 is 1, 4 into 12 is 3. 3 times 21 is 63. And what I like to do is draw a line under it. So I'm doing that again. That's 4. That's 3. This is the way I check myself, by doing the problem over again. Okay, good. Now, as I said, I like to bring all the x's to the left. All the numbers to the right. See, I don't like the way this, see this number here? That doesn't look like a 6 to me, so I'm going to change it to make it really look like a 6. That drops out, and this comes out to 12. X is equal to 12. And
Hey, Professor, could you just quickly go over how?
Can I finish my sentence and then you can
My
ask a
apologies.
question? If you have trouble dividing 6 into 72, feel free to go on the side and take your time and do it slowly. Or you could even use your calculator. Now, what was the question?
So I was just a little confused on how you removed the denominators on all of the fractions. I actually went about this a little bit of a strange way and did all the fractions. I put them all into something above 24. So I made it into 16, 24, 18, 24, 4, 24, 126, 24, and then simplified from there. I know I could have used 12, but I used 24 for some strange reason. But I'm just confused on how you removed.
Wait a minute.
Yeah,
First of all, you didn't use it for a strange reason. You used it for what I was saying before. You used the common multiple, a common multiple. It just wasn't the least common multiple.
yes,
It's
it was a little
okay
bit
if
more
you
math.
use 24.
Yeah,
That's not strange at all. Go
it
ahead.
worked. I got the same answer. I
In
was
other
just more
words, you
wondering.
changed everything to the same denominator. Is that what you're saying?
Yes, sir. I'm just wondering how you remove the denominators.
Well, let's take a closer look at that, okay? See, your method is a little complicated,
Definitely.
so therefore I would suggest this method. But let's use your number. You like 24, that's fine. You could use 24. Multiply everything by 24. I have no objection. Now, what I did was I basically, if you take it aside, I multiplied 24 over 1 by 2 over 3. And I got 24 times 2 is 48. 1 times 3 is 3. You got 16, right? 16x over 24. No?
Yes, I did.
Well, I mean, how would you get to 24? So yeah, that's it. So, but I didn't have a denominator. I just kind of did this. 3 into 24 is 8. 8 times 2 is 16x.
Yeah, so I guess I was just a bit confused on why you did that. I guess you were just removing the fraction, huh?
You're allowed to do that, yeah, but this is
You're
what I
actually
did,
right.
this is, I actually multiplied this, I made this into a fraction. I
Yes.
multiplied 24 over 1, let's say, times 2 over 3. I didn't use 24, of course, I used 12. And all that means is that you're going to get bigger numbers. You're going to get bigger numbers. So here, for example, you're going to get 4 into 24 is 6, and 6 times 3 is 18, and 6 into 24 is 4. You're going to get 4x, and 4 into 24 is 6, and you're going to get 126. I'd rather work with smaller numbers, but you can do it this way, and it'll come out to the right answer.
Okay.
If you want to use 24.
Yeah, it was more of a happenstance more than a want. But okay, so it makes sense what you're saying. I just like how simple it was when you removed the decimal. I am sorry, when you removed
Right.
the denominators from the fractions, it made the equation a lot easier to look at.
Right, exactly. And then, you're still gonna get the right answer though.
Yeah,
Like
exactly.
12.
So there's multiple ways to do it.
Many ways of doing it. I
Copy.
mean, somebody may have said, I don't like 12, I don't like 24, I want to use 48. Well, 48 will work because it's a common denominator or a common multiple, but it's going to be like gigantic numbers. The bigger the numbers are, the more difficult it's going to do, to be. Like I have to, I had to stop for a minute and add these two. But, I know that 63 plus 9 is going to be 72, but 126 and 18, it took me a couple of seconds to do that. But I would suggest the easiest method, which is the way I did it originally. But thank you for the question. It was a good
Professor,
question.
I know this might be a little repetitive, but I did it with 12. I did 3 times 4, and I got all the denominators to be 12, and then I just multiplied the numerators by the same numbers as the denominators, and I got the same answer.
Well, because that's exactly what the others, I forgot what the others, who said that, who's the other student? Who just spoke?
You're talking about me when I asked the question?
Yeah,
Yes, sir.
I mean, you basically did it Dakota's method, that's the same thing.
Just a smaller number. Okay, I just wanted to clarify that. Thank you.
Exactly. Uh-huh. Anybody else like to say something?
I have a question.
Marco,
So
yes,
using any multiple will still result in the correct answer.
absolutely.
Okay.
However, as I said, and I'll repeat it again, the bigger the number, the bigger these numbers are going to wind up. And, big numbers tend to result in incorrect answers sometimes. So you want to be very careful with that. Okay?
Okay.
All right. Thank you for the question, though. Good question. Anybody else? I'm staying on this problem until
Can I
I
ask a
feel
question?
Mahima, yes.
So can you use the LCM with any fraction equation?
Yes.
Okay, thank you.
Well, yeah, I guess so. I'm thinking of like strange problems now. Whenever I get a question, and my immediate, concept is to say, well, yes, you can do it, but yes, the answer is yes. I mean, we could have gotten 2x over 7 minus, 3 over 17. Yeah, it could get strange, but you're not going to have to deal with that here. I'm not giving, weird problems like this. This is above and beyond the call of duty here. I don't see the point of this, 1 over 13, for example. I mean, good luck trying to find the LCM with that. But I would never do that. I would never give that on a test. The test question would be something like this. But really, I have an even better question coming up right now. And that would be the question that I like the best. So before we go on, well, there are no questions. I'd like to go on. It's already 2:36. Let's move on. This is problem number 4 of this set. And here it is. I like this problem. That's all I'm saying. And I don't like the way I wrote this number. I don't like the way that number came out. Absolutely not. Okay, that looks more like a 2. Okay, I'll give you a little time to try that. So the least common multiple is kind of easy to determine. 3 and 6 and 2, it's obvious that 6 is the least common multiple. You could use 12. You could use 18. But I would rather use 6. So we're going to multiply everything by 6. Okay, now watch carefully, especially those of you who did it differently the first time. Watch this carefully. 6 into 3 into 6 is 2. Okay, so this number, and it's just like I'm multiplying 6 over 1. So really, you know, when you're allowed to cancel out this way. Students that I've had in the past have called that cross-canceling. I don't like it, but you know, it serves the purpose. 3 into 6 is 2. 2 times 2x is 4x. Minus 6 into 6 is 1. So that I'm going to put the 1, and I'm going to put this in parentheses. Just to show that this negative is not just for the x, that negative is also for the 2. All right? And then equals 2 into 6 is 3, and that's going to be 3 times 5x minus 2. So that's where we are right now. I'm pausing for a moment to give people a chance to both copy and to let it sink in. Okay, now 4x, negative 1x, negative 2 equals 15x, negative 6. All right, so what we want to do now is combine like terms. So 4x minus 1x is 3x. Minus 2 equals 15x minus 6. Now, I would like to do this. I know that there are people who would bring the 3x over there, but I don't mind using negative numbers. So I would do that. And that cancels out, and this becomes negative 12x minus 2 equals negative 6. I'm just looking at it because I'm checking it as I go along. I think it's very important to just kind of look at it and see that everything is the way you want it. Now, positive 2, negative 12x equals negative 4. divide by negative 12. And the negative divided by the negative will be positive. It comes out to 4/12. If this were an exam and somebody left this as 4/12, I would have to take points off of that because this is not in simplest form. This has to be in simplest form. And when I say simplest form, I mean reduce the fraction. And the answer is 1/3. Again, a decimal representation of that would be an approximate answer. I don't want the approximate answer. I want the exact answer. I'll let you look at that for a few moments. If you have a question, I'd be happy to do my best to answer your question.
Hello.
Estefany.
Hi. I just have a quick question. If
Sure.
like after all the math we did, it ended up being -4 over -12. How did the final answer end up x equals 4/12?
Because a negative divided by a negative is positive. When you divide two
Okay.
negatives, it comes out to positive.
Okay, I got it.
Okay? Good question. Thank you. Anybody else?
I have a question.
Marco,
So in the part that's x plus 2/6, I separated
wait.
each term
X plus 2,
before that step.
oh, up here.
Yeah.
Yeah, go ahead.
The way I rewrote it was -x/6 and then +2/6.
Oh, boy.
Yeah.
Really? -x/6 plus 2/6?
Yeah, I split them up into two separate fractions.
Yeah, but I understand that, but I want to get the signs correct here. You made it -x/6 and +2/6,
Correct.
as opposed to -x/6 and -2/6. See, that's wrong. And the reason is that you'll notice that when I then multiply the -1 here, the -1 goes for the x, but it also goes for the 2. So you would have gotten a +2 here.
That's
Instead of a
correct.
-2. See, let's talk about what you did. Let's talk about what you did for a minute because it's interesting. So you had 4x minus, let me write the original problem here. This is what you had, right? It's 2/2. This is what you had. You took the 4x minus x/6 plus 2/6, right?
Yeah.
The problem is, this is good. If you want to do this, you can do it if you want. So it actually, so you had 4x minus, okay, the problem is right here. Because that's not a positive. This is a negative. Because this negative goes for the x and it also goes for the 2. That's why I put it in parentheses. That's why it's not a bad idea to put parentheses around that, to show that the negative goes for the x and the negative also goes for the 2. Do you understand that?
Yeah, that if I would have seen the parentheses, I would have distributed the negative first.
Yeah, but it's not always gonna be laid out like that for you, so you have to know that. You know, that's one of the things that makes the course kind of difficult, is that they don't make it that easy. You're gonna wind up with problems that you have to know what to do, even if they don't sort of, move it in that direction. But if you want to have a problem like this, well, actually, what you did, I suppose, was you kept it as 2x/3, oh, no, did you? Yeah,
Yeah, that's exactly what I got.
you had 2x/3. But you had a positive here instead of a negative. That was the
Correct.
problem. That was the problem. Did you do it here also? 5x/2 minus 2/2?
Yeah, I ended up with a positive for the 5x, and then I kept the 2/2 as negative, so it was negative 2/2.
So you wound up with the same answer, but you had -1/3, right?
I had actually x equals 2/3.
Oh.
I was off by 1, but it's probably because of that -2 right there.
Yeah.
Yeah, I got the same exact answer by doing exactly what you did. It's like missing out the distributing the -1. I got 2/3.
Yeah, that was a good question.
That was a very good question. Very good question. But do you understand now why that's not correct? It's okay to make them into separate fractions, but that has to be a negative. That can't stay as a positive, because that negative outside, I made sure, if you go back to the original problem, I made sure that it was clear that that negative was pretty separate from everything. I could have made this less if I had done this. That's not what it was, though. That was done purposely to keep that negative over there. So it was really this. It was really this. But sometimes it's not going to be laid out for you so easily. So you're going to have to be very careful. Okay?
Thank you.
All right. Thank you. Anybody else? This is very, very interesting how people are doing the problem. I'm really pleased with the questions. Have been really wonderful, because it's helping other students. That's really great. So, everyone's thanking me, and I appreciate it, but really, I'm saying thank you, because that's a very, very interesting point. First of all, that you could separate them into two separate fractions. That's interesting. But second of all, you have to watch out for these negatives. That's a killer right over there. Okay, one last problem for this section. All right, so let me just say to you a very important thing. I like this problem. And that's all I'm saying. Okay, I'll give you a few minutes to solve that. I would put a 1 under that y. The least common multiple is 10. We're going to multiply everything by 10. Ten into 10 is 1. 1 times 2y is 2y. 1 times -9 is -9. 2 into 10 is 5. 5 times 3 is 15. And then 10y. And I'm just checking my work. 1, 5, okay. Combine like terms. So 2y plus 6 equals 10y. Now, I don't want to do -10y, -10y. because then everything will be on the left. So I'm gonna I have no choice but to bring over the 2y to the right side of the equation. This drops out. 6 equals 8y. Divide by 8. Y equals 6/8, which must be simplified. And when you divide by 2 in the numerator and divide by 2 in the denominator, you get 3/4 equals y. And if this is true, then by the symmetric property, the answer is 3/4.